Okay, so here is an alternating series problem. Let's plug in n equals 3. If I plug in n equals 3, I get negative 1 squared. I get 3 minus 1. I get 3 squared plus 3. I plug in n equals 4. I get plus negative 1 cubed, 4 minus 1, 4 squared plus 4, n equals 5. Negative 1 to the 4th, 5 minus 1, 5 squared plus 5. So this is, that's a positive 1, so that's 2 over 9 plus 3 is 12. That's a negative 1, and that's a 3 minus 3. 16 plus 4 is 20. That's a positive 4 over 25 plus 5 is 30. Feels very alternating. So therefore, note on if it's an alternating series problem, you don't need to show it's decreasing because I've already assessed that on you in an earlier problem. Just make sure that you write down that the series is, we're going to assume the series is decreasing. So the first thing I'm going to do is I'm going to check the nth term, or let's check as n goes to infinity, n minus 1. I want to make sure that it goes to 0. If it doesn't go to 0, there's trouble. I'm going to multiply top and bottom by 1 over n squared. This is the lim as n goes to infinity. 1 over n minus 1 over n squared. This is 1 plus 1 over n. This is 0 over 1, which is equal to 0. That's a check. We're going to assume it's decreasing. Just make sure on your quiz you write down decreasing, check. The third thing is I need to now show that this series here converges or diverges. I'm going to let me compare this to 1 over n because I'm going to ignore the negative 1 and I'm going to ignore the n. I just have n over n squared, which is just equal to 1 over n. So I'm going to use 1 over n equals 3 to infinity. This is divergent harmonic slash p series with p equal to 1. I now need to do a limit comparison. So I'm going to slide up a little bit here. I'm going to do the limit as n approaches infinity of n minus 1 over n squared plus n all over 1 over n. Notice when I do a limit comparison, it doesn't matter which one goes in the numerator, the one I'm trying to determine or the one that I know something about. So I flip and multiply. I get the lim as n goes to infinity of n minus 1 over n squared plus n times n over 1. I'm still good on space. I get the lim as n approaches infinity of n squared minus n over n squared plus n, multiplied top and bottom by 1 over n squared. I get 1 minus 1 over n, 1 plus 1 over n, which is equal to 1. Since I got a positive number that is not 0 or infinity, I've chosen correctly. So therefore, my series diverges by limit comparison. Make sure that you write down limit comparison because there's also a direct comparison that we're not going to be working on this year. Last thing I need to write down is absolutely or conditionally convergent. Since 1 over n is a divergent series, therefore this series only converges if it's alternating. So therefore it's conditionally convergent, and I need to write down alternating series test. Sorry, my handwriting's terrible. Okay, sorry to squeeze that in. So conditionally convergent alternating series test because this series up here is a divergent harmonic. So therefore by limit comparison, n minus 1 over n squared plus 1 also diverges. So therefore it's conditionally convergent under the alternating series test. Alternating series, why? Because this negative 1 to the n minus 1.